Sir, shall we start, sir?
Yes, sir, we can start, sir.
Yes, sir. Thank you. Good evening to the August gathering. Respected dignitaries, eminent resource persons, distinguished faculty members, and esteemed participants, it is with great pride and profound honor that I extend a gracious welcome to all of you to the day 6 of the 6 days online faculty development program on emerging trends in IoT, organized by the departments of Electrical and Electronic Engineering, Electronics and Communication Engineering, and Mechanical Engineering of Sriram Engineering College. As we advance into another intellectual stimulation section, we turn our attention to a domain of paramount significance in the modern technology landscape: edge computing and cloud platform in IoT. This subject stands at the confluence of innovation and application, shaping the future of intelligent and connecting systems. It is now my distinguished privilege to introduce our esteemed resource person for the day, Mr. Jim Reeves. Mr. S. Jim Reeves serves as an assistant professor in the Department of Artificial Intelligence and Machine Learning at Mallareddy University, Hyderabad, Telangana. He is also engaged in advanced research in the field of Internet of Things at Anna University, Chennai. His scholarly pursuits encompass object detection technique, IoT systems, and automotive engineering, reflecting a commendable blend of academic depth and practical relevance. Sir, your presence amidst us today is indeed a matter of great honor. With immense respect and anticipation, I now invite you to kindly take over the session and enlighten us with your valuable insights.
Thank you, sir. Thank you for your kind introduction, sir.
Thank you, sir.
Sir, it is visible, my slides.
Yes, sir. Sir, can you open that full screen, sir?
Yes, sir, yes.
Yes, sir. Now it's okay, sir.
Okay, sir, thank you.
Okay, thank you, sir.
Good evening to everyone. Today is the last session of that 6 days FTB. So in this today's topic, we are going to discuss something about edge computing and cloud platforms in IoT. So contents, there are 4 contents we are going to discuss today. First one is limitations of traditional cloud IoT. Already we are having cloud, so cloud-based IoT. So what are the limitations that the cloud IoT is having? That's the thing we will discuss first. Then we will move to the edge computing concepts. What is edge computing? How it is working? The technologies, everything we will learn. Next one, edge gateways. What is edge gateways? How it will function? Everything we will discuss in the third content. The last one is IoT cloud platforms, like AWS, Azure. So these two IoT platforms, IoT cloud platforms, we will discuss. So these are all the contents we are going to discuss right now. So first of all, we need to know something about cloud computing. I think all of us know what is a cloud computing. So cloud computing means storing and accessing the data and programs on remote servers that are hosted on the internet. What does it mean? I'm taking one picture in my mobile. I'm storing that that picture in my mobile. That is storing that data in my on-premises. That is my device. In case if I want to replace a new device, so I need to transfer all my data, that is pictures, to my new device. So instead of that, what I'm doing, I'm storing my data, that is my picture, in the Google Photos. So what will happen? The data, that is the picture, that will be stored on the Google Photos. If I want to change my device, so I can change my device without backing up my picture which was in my old device. So that concept is called cloud computing. That means using internet, I can upload my data to the cloud storage. The cloud storage in the sense it is a remote. Remote means somewhere else it will be stored. So the computing resources include physical or virtual servers. It can be a virtual server, or it can be a data storage, or it can be a networking capabilities, or it can any one of the application development tools or softwares and more. So the term cloud in cloud computing refers to the internet. As we discussed now, without internet, I cannot able to access my cloud resources. For example, I'm using a Google Sheet. So the data which are typing or which I'm entering in the Google Sheet, that can be done only using the internet. Without internet, if I'm updating means that is not possible. Without internet, I cannot able to upload my photos or videos in the Google Photos. So that's one drawback. So the term cloud in the cloud computing refers to internet. When we use cloud services, we are basically accessing remote service. Already we know that remotely the storage or the networking or the virtual service will be stored. So we are accessing that remote service from my location, wherever I'm staying. For example, now I am using, if I don't have any mobile or a laptop, what I will do? I will go to any one of the browsing center, computer center. There I can able to access my Google Photos. There I can able to see my pictures or videos or data which are I'm storing in the Google Drive or something else. So that means wherever I'm storing or what are the data I'm storing, I can able to access from anywhere else. That's the concept called cloud computing. And we can define cloud computing with another one name, pay as you go model, that we will discuss in the upcoming slides. So the cloud computing model gives user greatly flexibility and scalability compared to the traditional on-premises infrastructure. That means what? Flexibility in the sense, flexibility and scalability are irrelevant. So I will give some examples for scalability. Consider one example. Consider a Netflix. We used to watch Netflix rarely during the weekdays, like Monday to Friday. We people used to have access on the Netflix in a rare. So consider on Saturday and Sunday, that is weekends. Weekends, we people used to watch Netflix. That means what is happening on that particular day, particular weekends, Saturday, Sunday, and holidays. What will happen? Many users will try to log into the Netflix. On that particular days, what will happen? The servers will get busy. That means it will be heavily loaded. If it is heavily loaded, the servers cannot able to provide the content delivery correctly. So for that, the scalability plays a vital role. That means what does it mean? The scalability means based on that request given by the users, the resources will be automatically enlarged or dislodged. That means on Saturday, many users will try to access the Netflix. On the particular days, the resources, for example, the number of servers can be increased. Okay. So on Monday to Friday, the servers can be decreased. This concept is called scalability. And we can have more example like this. Consider Amazon or Flipkart, like e-commerce applications. During some offers, they will provide like a great Indian festival like Diwali or Christmas sales. Likewise, they will provide offers. On the particular day of sale, that particular websites will have more number of requests, more number of access. On that particular day, they need to increase the resources like servers, storages, everything they need to increase. So on the remaining days, no need to have more number of servers. On that day, they can return back the servers to the cloud providers. So this concept is called what? A scaling. So these are all possible in the cloud computing. So now we are going to learn something about cloud computing models. So these are the cloud computing models we are having. One is the private cloud, next one is a public cloud, next one community, and the last one is a hybrid. So from the name itself, we can able to identify what is a private cloud. So private cloud means there will be a dedicated cloud for a single organization. What does it mean? I want to store my data, my customer data securely. So for that, I can choose private cloud. For example, consider banking. So all my personal data like my Aadhaar number, my login credentials like user ID, password, everything will be stored in the private cloud. So if they use public cloud, what will happen? My data will be get leaked. So that will leads to hacking of my data. So for this kind of secure purpose, the private cloud is useful. And another one example we can say government databases like Aadhaar and taxes related services. So for that, they will use this kind of private cloud because no one should have access on my personal data. So for that kind of things, we can go for private cloud. Okay. Next, what is a public cloud? Public cloud in the sense, it is used by everyone, or we can say as services are open to the public. Services are open to the public through internet. What does it mean? I can able to use the SBI internet access, internet banking, or I can able to use Uber, or I can able to use Ola, I can able to use Flipkart, Amazon, anything. So that kind of things can be considered as public cloud. But what are the data I'm giving? For example, consider one example like banking. I can able to access my banking application through public cloud, but my data will be stored in private cloud. Some of the applications like considered like let us consider Amazon. I can able to access Amazon using my internet access, but the data like login credentials, that things will be stored in the private cloud. But using the public cloud, I can able to use the content which are delivered by the Amazon or Flipkart. So I can able to see what are the various products they are showing in the market, that I can able to see, but my data will be stored in private cloud. So next one is community cloud. Community cloud is a shared model, or we can say it as shared by multiple organizations that have similar requirements. For example, consider police control. So if I get arrested in any one of the station, what will happen? They will check my database throughout all the police station control through the centralized database. So if I got in any one of the police station, like if I got in Tirunelveli, my data which is available in Chennai, they can able to access. That means what? This kind of process is called community cloud. Within the community, they can share, but that particular data will not be shared with others. And we can give another example for community cloud is banking. So my login credential will not be shared with other banks, but what are the loans I have taken in any one of the bank? For example, I have took one loan in Canara Bank. Now I am going to ICICI Bank for another loan. What will happen? They will check whether this person is having any previous bank history, loan history, everything they will check. For this kind of things, they will have the community cloud. So all the data will not be shared in the community cloud. Only this kind of important things will be shared in the community cloud. These are the two best examples, like police and banking. Next one is a hybrid cloud. Hybrid in the sense, it is a combination of public and private. The first two, private cloud and public cloud combination is called as hybrid cloud. That means, consider this example. I'm using mobile banking or internet banking. Okay, that application is common. For example, if I'm using ICICI, so iMobile is one of the application that is common to all. Everyone can able to access the iMobile application. So that can be stored in public cloud. That application will be stored in public cloud. Okay, now I'm try to log in to the iMobile using my account detail, using my ATM card numbers, using my customer ID numbers. Using that, I am trying to log in. So that data will be stored in private cloud. So this is the difference. So that application that is available to all, that is stored in the public cloud. What are the data I'm giving, that will be stored in the private cloud. So in banking sectors, this will be enabled. That is hybrid cloud. They will have both the public cloud as well as the private cloud. So next one, we are going to see about cloud services model. So these are the basic things already we know. So once again, we can recall that one. So SAS, PaaS, IaaS. SAS in the sense software as a service, PaaS in the sense platform as a service, IaaS infrastructure as a service. So what is a software as a service? SAS. Best example we can give is YouTube. So YouTube is one of the software that is provided by the Google. They will provide the software. What I want to do, I want to just install that application in my mobile. Okay, using that software, I can able to use the services which is provided by the YouTube. What is the services they are providing? Videos. So I can able to access the video. So next example, Facebook. Facebook is one of the software. So if I install that software in my mobile, I can able to access the software. So this is called as software as a service. Only software they will provide, and services related to that particular software they will provide. That is called as software as a service. Before going to PaaS, we can move into IaaS, infrastructure as a service. Infrastructure in the sense, for example, if I'm running one company with 5 or 10 persons with 10 systems. So if I want to develop one AI model, so I can't able to afford that development using my system configurations. So that at the time, what I am doing, so I'm planning to go with the cloud vendors like AWS or Microsoft Azure. So I am approaching them. So I want to have only the system or only the computer I want. That is a hardware only I want. So I can configure the system using the cloud vendors. So if I rent some machines like in AWS, we will call it as EC2. So if I rent one EC2 from the AWS, that is EC2 is nothing but a computer, virtual computer. So I am renting one virtual computer with higher configurations. So that is called as what? IaaS. Only the hardware I will purchase from the cloud vendors. That is called IaaS. Okay, what about PaaS? Platform as a service. Platform as a service in the sense, I will have both software as well as the hardware. If I want to develop any application, so I can go with what? PaaS. So for example, I can rent EC2 from AWS. From AWS, I'm renting EC2, that is virtual machine. Along with that, if I want to develop any application, any softwares, I can rent the particular software. What are the software I want? I can purchase from the cloud vendors. So what will happen? So I can minimize my time, or I can save my time in maintaining these kind of things, maintaining the hardwares, maintaining the softwares, maintaining the antivirus, everything. I no need to worry about that. Everything the cloud providers will do. My job is to develop the application. So in the meanwhile, what will happen? I no need to spend more time and more money on that purchase or installment or develop or the infrastructure development. So this concept is called as cloud service model, software as a service, PaaS and IaaS. Now, even though if we are having a lot of advantages in cloud, now we are going to see some limitations of traditional cloud like AWS or Azure related to the IoT. Even though if it is even though if it is having a lot of advantages, some few drawbacks are there related to the IoT. The first one is, due to the development of IoT, people are using large number of IoT devices. That means a lot of data are being generated. According to a report says, each and every day, nearly 0.2 zettabyte of data are being generated using only IoT devices. Zettabyte is 1 zettabyte is equivalent to 1 billion terabytes. That means a huge number of data are being generated every day. So what is happening if large number of data are being generated? The cloud cannot able to handle all huge value of data. So it will be a headache for the cloud providers, or it will be a overload for the cloud. So in order to avoid, we are going for the edge computing. So in this case, the edge concept arrives. The next one, the network bandwidth of a cloud computing has been unable to meet the needs of time sensitivity systems and real-time performance. That means bandwidth in the sense they are referring with the speed. The time sensitive systems, for example, consider autonomous cars. In autonomous cars, the time taken to take the decision whether I need to apply brake or I need to put indicate a signal to the right or left, or I want to increase the speed, I want to decrease the speed, the decision taking time is very less. So for that kind of time sensitive systems, we cannot rely on traditional cloud systems. So before the emergence of edge computing, traditional computing transfers all the data to the cloud computing. So what are the data that are generated by the IoT devices that will be sent to the cloud? Okay, for example, in AWS, the architecture can be divided into regions. There are only two regions available in India for considering AWS. Two regions. One is Mumbai and another one is in Hyderabad. So that regions can be further divided or classified into availability zones. Availability zones will be split over the regions. So if my data, if I was in South India, that is South Tamil Nadu, like Kanyakumari, if I am in Kanyakumari. So if I want to transfer my IoT data to the cloud, especially AWS, the data should be sent to the nearby availability zone. That data will be further shared with the region that is located in Hyderabad, that is nearest to Kanyakumari. So if anyone is in Kashmir, the nearest region will be the Mumbai. So this is the case. So what will happen? Some delay will occur. So in order to avoid this kind of delay, we are going with the edge computing that we will discuss in the upcoming slides. In the context of IoT, if all the large amount of data generated by the connected devices are transmitted to the cloud computing will cause a large load. Already we discussed. A huge amount of data are being generated every day. Consider a smart factory. Each and every day, terabytes of data are being generated from the industrials. If you are considering autonomous vehicles like Tesla cars, it will generate nearly up to 4 to 5 terabyte of data per hour. Each and every hour, it is generating 4 to 5 terabyte of data per hour. That means per day, how much data it is generating. Nowadays, everywhere we can able to see smart homes. Smart homes is also producing nearly 1 GB of data per home. We are can you able to imagine how much of data will be generated from the IoT devices? Smart homes itself, it is generating 1 GB of data approximately per week for a single home. That means a huge amount of data are generated. This is causing the cloud to be overloaded. For this kind of things, we are going for the edge computing. Okay. Now we are going to see some limitations with the technical terms. Latency. Latency in the sense delay. We can define latency with delay. Already we know that cloud are stored in a distance or far away from the IoT devices. Cloud storage are located far away from the IoT devices. For time sensitive devices or applications like autonomous cars, there should not be any delay. If and another one example we can say is as health monitoring. So in IoT applications like autonomous cars or autonomous vehicles, nowadays autonomous bikes also arrived. So autonomous vehicles or health monitoring systems, Even a small delay can be a dangerous one. So in order to avoid, we are going with the edge computing. So that's why we are moving to the edge. So this is one limitations that is occurring in traditional cloud, that is the latency. Second one is internet dependency. As we discussed earlier, without internet, I cannot able to access the cloud resources. For example, if I want to upload one picture which I was taken now, without internet, I cannot able to upload. With mobile data or using Wi-Fi, I can able to upload that picture to the Google Photos. Okay, if I want to access uh, Google Sheet without data, I cannot. Without internet, I cannot able to access that one. So these are the drawback which is applicable in the traditional cloud IoT. And consider a smart home. If power failure occur in the smart home and due to Wi-Fi disconnectivity, I cannot able to access the smart homes functions. So these are the some drawbacks which is available in the cloud IoT. Next one, bandwidth issues. Already we discussed this thing. The cloud, due to the high generation of data or a continuous generation of data, a huge amount of data is produced each and every day. So this will cause the cloud overloaded. So consider the smart cities. In smart cities, smart traffic lights are there. So each and every traffic light, nowadays you can able to see ATC in each and every smart cities. They are implementing traffic signals with ATC. You can we cannot able to see the timing. In normal traffic signals, we can able to see the timing. The time will get decreased. For example, 30 seconds become 29, 28. Likewise, it will go to 0. Next, the signal will turn into green or red or something. So nowadays we cannot able to see that kind of things. Instead of that, you can able to see ATC, automated or automatic traffic control. That means what is happening there? There will be cameras that will take pictures and it will analyze and it will sense how many vehicles are present in a particular lane. Based on the number of counts, the traffic signal will automatically change its signal from red to green or green to red. Likewise, it will change. So it is happening based on the number of vehicles present in a particular lane. If particular lane is empty, that particular lane will become automatically turns into red. If particular one lane is full of vehicles, that lane signal will turns into green. So this is happening. So for this, that data will be generated based on that sensing of the data. So if we send this all this data to the cloud, consider only one traffic signal. In a smart city, we will have multiple traffic signals will be there. So if you consider the entire nation or entire world, huge amount of data will be generated. So if we send all this data immediately to the cloud will get overloaded. So this is the one drawback in that is called as bandwidth issues. Next one is security issues. Security issues in the sense hackers can able to access the smart cameras. Recently in newspapers we can read that Israel have hacked Iran's all traffic cameras, and majority of the cameras they have hacked. So this is one of the drawback in the security. This is one of the drawback which is occurring in the traditional cloud. So security risk is more in the cloud IoT. So next one is data privacy concerns. Data privacy in the sense, if I'm using my fitness wearables like smart watches or anything, so that data, if I am sharing in the cloud using the internet, if the data was hacked, so I cannot able to hide my data, my privacy. I cannot able to have my data as a privacy one. So this is also one of the drawback that is available in the traditional cloud. So next one is scalability challenges. Scalability in the sense already we discussed there are two types of scalability: vertical scaling and horizontal scaling. Scalability, vertical scaling in the sense we can have one device can be upgraded. For example, if I'm using a server with 8 GB, now I want to scale up my server. So I can increase my 8 GB to 32 GB. That is called as vertical scaling. So horizontal scaling in the sense, if I'm using one server for processing my request, so suddenly I got increased or more number of requests. So what I will do, I will add one more server due to or based on the request arriving. So I can increase my number of servers. That is called as horizontal scaling. So consider industrial, consider all industrial things. Nowadays, all the industries are automated. Maximum 90% of industries are being get automated. So in each and every industries, there will be lot of IoT devices. Each and everything will generate large number or huge number of data. So for that kind of things, we cannot able to scale up the number of increase in the request from the industries. And not only in the industries, the smart agriculture, we can able to see lot of IoT applications, smart cities, and in healthcare, these kind of things will generate lot of requests. So for all the things, the traditional cloud cannot able to scale up the challenges which are occurring in the IoT environment. Next one is reliability issues. Reliability in the sense we cannot 100% rely on that particular cloud. For example, some natural disaster is occurring. For consider one region is available in Hyderabad, and one availability zone is available in, for example, Madurai. I am in Kanyakumari. So what are the data I'm generating that will be stored in Madurai? Okay, something is happened near the Madurai. For example, some earthquakes or natural calamities are occurring, or a flood is occurring. So what will happen? All my data which are stored in that particular Madurai availability zone or in the Hyderabad region, that will get affected. Due to that, I cannot able to continue my process. For example, many industries are based on internet and IoT ecosystems. So based on that data processing and analysis only, I can move further. So if the data being get affected in the availability zone or in the region, what will happen? So my productivity will get lost. So it will lead to loss for any one of the factory. So this is one of the drawback that will comes under reliability issues. Next one is downtime issues. Downtime and reliability are very similar. Downtime in the sense, for example, if Microsoft Azure is down for a few minutes, what will happen? Consider one autonomous car. I am driving in an autonomous car. Suddenly, Microsoft Azure, I have enabled my cloud resources in the Microsoft Azure. Suddenly, Microsoft Azure got down for a few minutes. What will happen? My device cannot able to decide how to react to the particular situation. So this will cause a severe issues in the environment. So these are the limitations of the traditional cloud. So consider this example. If I am driving in a autonomous car, surrounding cars are not autonomous. Okay. Now I want to take decision whether the in front car is going slow or they are slowing down or going fast. Everything I need to decide within a fraction of a second, and I need to judge and I need to apply whether I need to decide whether I need to apply brake or I need to apply acceleration or whether I need to turn right or turn left. Anything I need to decide fraction of second. So if I'm driving that autonomous car in Kanyakumari, my data availability zone is available in Madurai. So distance is nearly 200 to 300 kilometers, 300 kilometers. Let us consider 300 kilometers between Kanyakumari and Madurai. So what will happen? some latency will occur. Some latency in the sense my data or the sensors will detect objects and it will send the data to the cloud. So from the cloud only it has to compute whether the vehicle has to apply brake or it has to apply acceleration or it has to apply indicator or whatever the things it has to do, that will be computed in the mother zone. So from there I need to receive the feedback, then based on that I need to work on it. For this it will take some fraction of second. So this kind of applications need instant decision making. So if I'm riding with a kilometer under 120 km speed, suddenly one animal like a goat or a cow is crossing that road, suddenly the vehicle has to stop the vehicle or apply brake. For this kind of instance, we cannot we cannot depend on the traditional cloud. So for this kind of applications, we need edge computing. Edge computing in the sense within that vehicle there will be a computational process. It will compute immediately and it will give the feedback. Based on that feedback, it will apply brake or it will give acceleration based on that current environment. Consider this agriculture. Suppose my data are stored not in the edge. Instead of that, I'm using cloud. So at some of the time, some bad insects will come. So my IoT devices is sensing that some bad insects are arriving at the agriculture plant, agriculture land. So now I want to spray the fertilizers. So in order to avoid the loss in the crops. So if I depend only on the cloud, what will happen? It will take time. So for that, it will take for let us assume 1 or 2, 3 minutes. Within that 3 minutes, if the some of the pesticides, some of the insects may do some harmful things. For example, if one of my cloud providers get down, on the sense at that time I cannot able to get feedback from the cloud, and I cannot able to do the automation like whether I need to spray it or not. That I cannot decide now. So in this case, edge computing will play a vital role. So this is industrial IoT based. So in industry also everything is IoT based. So all this data will be generated. So even a fraction of second, delay in the fraction of second can also lead to some errors in the production units. It is very important. Production unit like packing the snacks like bingo or something, lace, and car manufacturing. Precision is very important. If some fraction of second is delayed, the precision will go. So these are the some drawbacks or limitations in the cloud, that is traditional cloud IoT. Now we are going to see about what is edge computing. Edge computing is a computing model where data is processed near the source. What does the near the sources means? Consider autonomous car. We are going to consider one autonomous car. Autonomous car will have LiDAR sensors. The LiDAR sensor, what the LiDAR sensor will do, it will generate or it will emits laser lights. Based on that reflection time, it will detect the object, whether it is present nearby or far. So the distance calculation will be done within that car. No need to go for the cloud. So that concept is called data is processed near the source. My car is the source. My car is emitting laser light. That light is going and hitting the object which is present in the opposite, and it is coming back. Based on that time travel, I can able to calculate the distance between my car and the opposite vehicle. So based on that, I can apply brake or I can give acceleration. The decision will be taken within that particular car itself. This concept is called as edge computing. Edge is nothing but edge within the network. So edge computing involves running computer programs that deliver quick responses close to where requests are made. That means my request given by the car is whether any object is present near me or opposite to me or behind me or beside me. So that request is made by the LiDAR sensors. The sensor sends some signals. Based on that reception of that signals, I can able to justify whether objects are available near to that object, my source or not. So everything will be computed within a quick response. So everything will be calculated within a fraction of time, and it will be fed back to the system itself. That is called as edge computing. So edge computing occurs outside the cloud at the network's edge. Within that network's edge, I can have the computing works, especially for applications needing immediate data processing. You can consider health monitoring systems. Suppose I'm wearing one smartwatch. Okay, in my smartwatch, I can able to monitor my heart rate. I can able to monitor my oxygen level. So without internet, I can able to monitor. Suddenly, while I'm in sleeping, I don't know what is happening around me. So if I'm in sleeping, if I'm feeling or if my oxygen level is getting decreased, I'm wearing my smartwatch in my hand. So at the time I was sleeping. So if my oxygen level is getting decreased, so automatically it will observe my oxygen level using the sensor which is present in that smartwatch, and it will send or it will process that signals which is received by the sensors within the watch. Okay, and it will generate report or it will alert me. Okay, it will warn me. So some notification will be coming to my watch. Okay, so if I am enable this or if I connected this mobile this watch with my mobile, what will happen? Some notification will be sent to the mobile. So these are the things that will happen in the edge computing. So edge computing occurs or it can be implemented for applications needing immediate data processing. So if I am feeling unwell, like my oxygen level is very low. So if my data is to be sent to the cloud and the cloud has to process my data and it has to send the request back to me. In case if I don't have any network, what will happen? I can't able to send my data to the cloud. I can't able to receive the data from the cloud. So finally, health issue will occur for me. So what will happen in the edge computing? Within the watch, we will have edge devices like what are the sensors will generate signals or it will sense what is happening in my body. So if my oxygen level is very low, it will notify to the edge device and it will calculate, okay, your health, your oxygen level is low. Then what automatically it will generate some alarms or message to me to notify that your oxygen level is low. So something like vibration will occur. If I get wake up, okay, I can able to feel that I'm feeling unwell, so I can take some remedy. So this is the advantages of having edge computing over the cloud computing. So history of edge computing, if we consider history, edge is evolved based on the content delivery networks. Already we know that is content delivery network. This is also available in the cloud itself. But comparing with the edge, content delivery CDN is not more effective. So what is a content delivery network? If I want to deliver any content in a rapid way or a quick way, I can go with the content delivery networks. For example, currently election is going in Tamil Nadu. So what will be the people's search every day? So every day the people will use to scroll or search previous Tamil Nadu election histories and current alliance party alliances history. Everything they will search related to the elections. So this is a content that is needed more for the Tamil Nadu people. So in content delivery networks, what will happen? This content will be kept in the front. For example, in simple way, we can say, if I'm running a grocery shop, what are the content that will be sold frequently? For example, if I'm running a shop opposite to a school, the most selling contents will be pen, pencil, eraser, and chocolates. These are the things that will be sold frequently and repeatedly. So these are the contents I will keep in front. near to the cash counter. Because if I keep this content at the back, what will happen? Every time I need to go back and come front. So it will create more delay. So instead of that, what are the things that is asked frequently by the customers that will be kept near the cash counter. So I can able to deliver that products easier and quicker to the customers in order to save time. So in the similar way, this content delivery networks will work. So that concept was implemented in the edge computing. Okay, already we discussed this point. Why we are going with edge computing is to reducing latency and improving performance. In 2012, Cisco Systems introduced the term fog computing. Fog computing is an evolution of cloud, but considering edge computing, we can relate edge computing with the fog computing, but fog computing is for overall, but we can relate edge computing with fog computing for a smaller circle, like smart cities or for an industry, for an automated homes. Likewise, we can relate the fog computing with the edge computing. So due to the evolution of the 5G network also, that edge computing get very highly developed with ultra low latency and high speed connections. It is possible due to the 5G connections. So now we are going to see about the architecture. In architecture, it's a simple architecture. So 3 layers. One is the device layer, next one is the edge layer, and the last one is the cloud layer. Edge layer is nothing but what are the devices that are connected with the edge. That is called as device layer. For example, mobility. In the screen, you can able to see first one is the device layer, mobility. Mobility in the sense we can have mobile phones or smart watches or tablets, anything can be considered as mobility. So this, for example, I'm wearing smartwatch. Okay, my health is being monitored using that smartwatch. If I'm feeling any abnormal heart rate or low oxygen level, it will sense or it will alert immediately or instantly. It will message me that you are having high heartbeat and low oxygen level. These are the things it will mention me or it will notify me. So these are the devices that will able to give the notifications. So considering the mobile, in mobile we can able to see the Google Maps. For a best example is a Google Map. In Google Map, live traffic will be updated. Whether the traffic is more or not, everything will be updated. And another example we can say is that if you are booking any vehicle like bike or car or auto in Uber or Ola, something, so the driver locations can be updated. So these are the applications that can be enabled with the edge. So next one is the automotive. Automotive in the sense like smart cars and autonomous vehicles. Smart car is different, autonomous vehicle is different. Autonomous vehicle in the sense completely driverless. Without driver, the car will move from one point to another point. But smart cars are different. Nowadays, Mahindra vehicles are producing a lot of smart cars like automatic parking, but we need to drive. Fully automatic is not automated is not available, but they can park the vehicle without the drivers. So this kind of cars can be considered as smart cars. So in automotive, this kind of smart cars, autonomous cars will help that can interact with the edge servers in order to have a quick response. So for what reason this kind of things are going with the edge? In order to avoid collisions. Next one, robotics. Robotics that we know, even in the hospital itself, robotics plays a vital role. In surgery also, this kind of robotics are useful. For precision operation, we need immediate responder. For that, we cannot depend on cloud servers. So we are going with the edge. The robot will be connected with the edge layers, that is edge servers. The edge servers will decide what to do and it will respond. What are the data that are generated by the robots that will be stored in the edge server? If I want to store all the data which are generated by the IoT devices, then I can store in the cloud server. So cloud server is an optional for me. So already we discussed the factory examples. In factory itself, we can able to detect machine failure before breakdown, and quality control we can able to have, like cameras can detect defective products instantly. If you are using cameras for in the previous olden days, quality people for quality checking, people will be deployed to check the quality or check any defect are available in the products. Nowadays all the factories are changing to IoT concepts. They will fix cameras and IR devices that will scan, and if any defects are available, it will report immediately, and based on that report, that employees will replace that defective products. So in order to produce a quality products, we are going with this automated. So in our industries, we can have these kind of things. And last one is field services. In field services like oil in the sense rigs. Rigs, we know that there we can have crude oils. So this in this field also we are having this kind of IoT devices. So that will also link with what edge servers. And in this architecture, we can also include agriculture. Agriculture also we can include, and healthcare also we can include, like hospitals also we can include. So that means what, all the IoT enabled devices are nowadays going with the edge concept only. So based on the edge, I can, if I want to store my data, then I will go with the cloud. If I don't want to store my data, I can end up with within the edge layer. So within that edge layer, I can complete. So this is the basic architecture we are having. So next one we are going to see about edge gateway. So it is an intelligent device that acts as a local command center. So it is a powerful device, serves as a bridge between that what we can say, the devices which are connected with the IoT and with the cloud. It is a bridge between IoT devices and the cloud. In the simple way we can say. And also it will have a command center. Command center in the sense, it will do all the computational work. All the computational work will be done within the gateway. So an edge gateway that is positioned close to IoT devices like sensors or machinery at the edge of the network. Within the network, this gateway will be positioned so that the sensors data, accumulators data, everything will be received and it will be processed within that gateway, and it will send the feedback to the devices what to do. So it's a primary function to collect, process and filter the data locally. The primary function of gateway is to collect the data which are generated by the IoT devices, and it will process in the sense it will compute what to do, and it will filter the data. What are the data are needed, what are the data are not needed. So these are the things it will do, and it will send the relevant data or needed data that to be stored in the cloud. For example, I'm using a traffic, I'm going with one traffic, automated traffic, like ATC. At a particular time, on a particular lane, there is less number of vehicles. On the same time, on a particular lane, more number of vehicles are there. So here I can able to analyze, I can able to process. Okay, on a particular day, for example, consider one day like a Friday. On every Friday, on the particular lane is full of free, particular lane is full of busy. That means this process will be analyzed within that gateway, and it will send the data to the cloud. So based on that decision we can take. So on a particular day, we can enable or we can change the particular route. Okay, why this route is busy on a particular day, on a particular time. So if you are planning to change any one of the route, we can do that one. So that is possible using this kind of edge gateway. So it will connect multiple devices. For example, I am using one smartwatch that works based on the Bluetooth. Okay. if my house is fully automated, my house will works based on Wi-Fi connections. So different types of protocols I'm using. So in order to access the cloud, I cannot be able to what I can say. We cannot able to uh, design our own environment. For example, I want to store my health records that is stored in my smartwatch that uses Bluetooth. I want to store my home automated data that that should be stored in the cloud. For that, I can rely only on the edge gateway, because this gateway will translates the protocols that will be standard for to store in the cloud. So this is called as protocol translations. So this edge gateway plays a vital role in translating this protocol, which are generated or which are working in different protocols. So one of the most important role of an edge gateway is local data processing. Already we know edge is nothing but local data processing. Local data processing in the sense, what are the data generated by the sensors, accumulators, everything that will be processed nearest to the computational network called edge. So this is one of the best or important role in the edge. So that will be done within the gateway. So the role of the gateway is to get the data from the nearest sensor and it will process. That is the main role of the edge gateway. Instead of sending huge volume of raw data to the cloud, the gateway can analyze the data locally. Already we discussed this thing. This this edge gateway will analyze, or it will gather the information from the sensors. It will analyze the data locally within the gateway. It will analyze and it will decide what to do and what not to do. So it will analyze, and based on that, it will take decisions. Okay. For example, if I want to store some data to the cloud, then it will allow me to store the data in the cloud. Consider a smart factory. Sensors may continuously monitor machines' temperature, but the gateway will send alerts to the cloud if the temperature crosses a threshold. We can consider this example. I think everyone we have seen BTS. BTS in the sense base transceiver station. I think we have seen the mobile towers. At the bottom of the mobile tower, we can able to see one small room. That room is considered as BTS, base transceiver station. So inside that base transceiver station, a lot of equipments, electronic equipments will be there. If that device get failed, all the networks covering that tower will go into hacker. Okay. So what will happen? What the people will do? They will maintain the temperature less than 20 or 25 degrees Celsius. If the temperature increases to 30 or 35, some malfunction will happen. So it will cause to failure of that particular tower. Not only that particular tower, it will reflect throughout that entire MSC or entire BSC. It will reflects. So what the people will do, they will use to maintain the temperature by using the ACs. It will be fully, it will looks like fully centralized AC. That room will be fully chill. Sometimes due to power failure, the room, the AC will, AC power will go off. At that time, the temperature will get rise. At that particular period of time, threshold value, they will set the threshold value with, for example, 25 degrees Celsius. At that time, what will happen? The alarm will go to the particular engineer, like a maintenance engineer, that alarm will go. Once the engineer engineer received any notifications or alarms, they will go immediately to that particular location and they will rectify that problem. So in order to avoid the failure. So these are the things that can be done using this kind of local data processing. So this significantly reduces bandwidth. Bandwidth in the sense we no need to upload this data to the cloud. So this will reduces the bandwidth usage. So improves the system efficiency automatically. So another major role is reducing latency. Already we discussed the same point, reducing latency. Latency in the sense delay. Already we know latency means delay. Why delay will happen in the cloud? Because the data center and the particular IoT devices location will vary. So it will have nearly more than if you are considering AWS, Madurai is one of the availability zone. Means if I'm working in Kanyakumari, the distance will be 300 kilometers. So for 300 kilometers, it has to travel and it has to come back. Some delay will be there. Even a second can cause impact in time sensitive applications like autonomous cars. So if 1 second is delayed, crash can happen in the cars. So for that purpose, we are going with the edge computing concepts. So edge gateways will play a vital role in reducing latency. So since data is processed closest to the source, already we know what are the, for example, consider the same. Autonomous car is generating signals or generating data based on the LiDAR sensor. The LiDAR sensor will sense and it will give the report or give the data to the gateway. The gateway will respond whether I need to apply the brake or whether I need to apply acceleration, whether I need to slow down the vehicle, everything that will decide. Whether I need to gear down the vehicle, everything it will decide and it will do the task accordingly. Another key function is security management. Already we discussed in security management. If I'm using one automated home, so the data which are storing in the cloud, if it is hacked by some hackers, so they can able to know at what time I am getting into the house, at what time I am leaving, at what time I am going to buy for my sleep, at what time I'm having my lunch, having my breakfast, everything they can able to monitor. So this is one of the highest security concerns. So if I'm using a smart camera, so if the data are being hacked by the hackers, so it will be a security concern for me. So this kind of things can be overcome using this edge gateway. So the gateway acts as a protective layer between devices and the cloud. Actually, it will create one layer. It will act as a layer between the IoT devices and the cloud. So by implementing encryption, already we know these things, encryption, authentication, and firewall mechanisms. It will have some encryptions. Based on that, it will works. So this is one of the major key point in edge gateway. So next one is the device management and control. Device management and control in the sense it will check the health of that components which I am having in the internet or IoT ecosystems. It will monitor the health of the devices and what are the software updates I need. It will provide, and it can able to control the device locally. Without internet, we can able to control the devices. So these are the things that the gateway will do. Yeah, already we see this is useful in situations where internet connectivity is unstable. For example, if I'm having a smart agriculture, so if I'm using agriculture land, we know that it will be far away from the village or from the cities. So at that particular point, if I'm not able to have a proper internet connectivity, so I will have a less connectivity. Like sometimes I will have 2G, sometimes I will have 4G, sometimes I will have 5G. So it will be in an unstable one. It will not be in a stable one. So for that kind of things, this kind of gateway will helpful by analyzing the data which are generated locally. So this is the main advantage we can say. So this is the gateway architecture. So the devices OT world is nothing but that are the devices that are connected with the gateway. That is called as operational technology. OT is nothing but operational technology. The devices, IoT devices that are connected with the IoT gateway. The IoT gateway will be connected with the IT world. That is nothing but the cloud. The cloud or IT is nothing but global information technology. So IT world is nothing but a simple word we can say as cloud. The gateway will be connected with the cloud. The IoT devices will be connected with the gateway. The gateway is the main role having, it will do all the process within the gateway itself. So this is one of the example picture for edge gateway. Robustel company have this kind of things. It is a compactable one. It will looks like our home Wi-Fi router. The size of that this size of this gateway is similar to the size of our home Wi-Fi router. So the last we are going to see about IoT cloud platforms. So AWS IoT key services. These are the platforms we are going to see. In AWS, we are having 5 major key services like IoT Core, Lambda, S3, DynamoDB, and IoT Analytics. IoT Core is nothing but a service that is provided by the Amazon Web Service that can connect and manage IoT devices securely. So it is a service that will connect the IoT devices used through the edge gateway. Through the edge gateway, it can able to connect the IoT devices. So this is a role done by the IoT Core. Lambda, AWS Lambda, we will call as AWS Lambda. Lambda is nothing but a serverless compute. Serverless compute in the sense, without that meaning is not that without server, the server will be there, but we will not maintain that server. The cloud providers itself, they will maintain the servers. That concept is called AWS Lambda, that will process data without managing servers. We no need to manage the servers. The AWS cloud itself, they will manage the servers. S3 is nothing but a storage, simple storage service. In AWS services, one of the services is S3 for storing the IoT data. What are the data that are generated by the IoT devices that can be stored in S3? Simple storage service that we will use to say. Next one of the services, DynamoDB. DynamoDB is used to store the NoSQL databases for real-time data. So these are the data can be stored in the DynamoDB. So last one service is IoT Analytics. IoT Analytics is used to analyze the IoT data. What are the data generated by the IoT devices that will be stored in DynamoDB? So that data will be processed in the using the service called IoT Analysis. So next one, Azure. So Azure IoT key services are, these are the 5 services. So first one is IoT Hub. IoT Hub is similar to IoT Core, which is available in AWS. So in Azure, they will call us Azure IoT Hub. That will helps us to connect and manage devices, similar to what AWS IoT Core. Next one, IoT Edge. In AWS also, we are having one concept called Edge Location. Here also, they will have one concept called IoT Edge. This will help the process to it will help the data to process at the edge of the devices. Okay, that is one advantage over the AWS. Next one, Stream Analytics. Stream Analytics in the sense, it will process the real-time data. So real-time data in the sense, what are the data that are generated in the traffic signals? For example, in the smart cities, they will check the pollution rate. Everything they can able to check that data, that the data can be processed, that are data generated in a real time. So this data can be considered as real-time data that can be processed using the streamline analytics. Okay. Next one is digital twins. It will create virtual mode of systems. Virtual mode of systems in the sense we can able to virtually access the systems. That is called as digital twins. Last one is the blob storage. Similar to DynamoDB, here we will use one storage called blob storage. Stores a huge number of data. If you want to store a huge number of data, we can go with Azure blob storage, because IoT devices will generate, already we saw that one, it will generate nearly 0.2 zettabytes of data per day. Throughout the world, it is generating 0.2 zettabyte. 1 zettabyte is equivalent to 1 billion terabytes. So we can able to imagine how much data that IoT devices are producing every day. So it will not stop within this 0.2 zettabyte. It will increase every day, because each and every day The IoT devices are been increasing. The industries are going with all kind of IoT devices. The vehicles are going with automations. So everywhere automations are going on. So finally, we can conclude that. So IoT, if you want to have IoT environment, we can go with the edge computing because it is faster compared with cloud. So that's all about my session. Thank you for everyone for watching this one. Thank you.
Thank you, sir. On behalf of Sriram Engineering College, it is my proud privilege to express our deepest sense of gratitude to our distinguished resource person for delivering an exceptionally profound and illuminating session on edge computing and cloud platform in IoT. So your eloquent exposition and scholarly insight have greatly enriched our intellectual horizons and provided us with a deeper understanding of this rapidly evolving domain. So at this juncture, we would be delighted to open the floor for interaction. So participants and faculty members are cordially invited to present their questions or seek any clarifications. Hello, hello.
The today's program was wonderful. The presentation was good, highly appreciable. Thank you.
Thank you, sir. Thank you very much, sir.
Hello. Hello.
Tell me, ma'am.
Good evening, sir. Today's
Good
session
evening.
was very wonderful, sir. Excellent, sir.
Okay, ma'am.
It was
Thank
very
you, ma'am. Thank you.
interesting.
Thank you,
Sir,
ma'am.
I have a query. Is it
Okay, ma'am. Tell me.
you were telling about IoT, no, sir? It is applicable to IoT. Is it similar for cyber physical system also? Same concept only, no, sir? For cyber physical system. So, is it applicable even for cyber physical system?
Oh, yes, ma'am.
Okay, 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 sir. Okay, sir. Thank you, sir.
Thank you, ma'am. Thank you.
So once again, we placed on record our sincere appreciation to the resource person for an inspiring and intellectually rewarding session. So it is now my honor to invite Dr. L. Sivagami, Head of the Department of Electronics and Communication Engineering, to deliver the vote of thanks.
Good evening to one and all present here. It gives me immense pleasure and pride to deliver the validity address for this 6 days faculty development program on emerging trends in IoT, jointly conducted by Department of Electrical and Electronics Engineering, Department of Electronics and Communication Engineering, and Department of Mechanical Engineering. First and foremost, I would like to express our sincere gratitude to our Honorable Chairman N. Narayanaswamy and our Secretary MDG Rajkumar and other trustee members and our beloved Principal Dr. B. R. Ramesh Babu and Dr. B. Mahesh of Triply Department for their constant support and encouragement in organizing this FTP successfully. Nearly 400 participants have registered for this event, and over the past 6 days, this FTP has been a remarkable journey of learning, exploration, and collaboration. The sessions conducted during this FTP have covered a wide spectrum of topics from IoT architecture, IoT communication technology and protocols, IoT for smart grid and energy management, IoT applications in smart systems, IoT in avionics, and using Gen AI to analyze the sensor data, behavioral IoT, and edge computing and cloud platforms in IoT. These sessions have not only enhanced the technical knowledge but also provides practical insights into real-time applications. I extend my heartfelt thanks to all the distinguished resource persons, Mrs. K. Devadarshini from Pollachi Institute of Engineering and Technology, Dr. D. Satyaraj from Arvind College of Technology, Dr. K. Srinivas from Sri Ram Engineering College, Ms. Annie Grace Vimala from Savita School of Engineering, Mr. S. Jim Reeves from Mallaredi University, who shared their valuable knowledge, expertise, and the real-world insights in the field of IoT. I would also like to return our sincere appreciation to the esteemed resource persons to our principal Dr. B.R. Babu and Dr. S. Krishnakumar, Professor and Head Ripley Department from our host institution for their invaluable contributions. I'd also like to thank the organizing committee and the conveners, namely Dr. S. Krishnakumar for organizing the event, Dr. B.R. Babu for organizing the session,
Excuse me, due to some technical issues, Madam will be logging again. Ma'am, hello.
Ma'am, your mic will be on. பேசுறது கேட்கல.
Sir, sir,
Yes, ma'am. Yes, ma'am.
audible இருக்கா?
Yes, ma'am. Kindly continue.
Okay, sir.
Hmm.
Good
No,
evening
mic
to
mute
one and
sir.
all, sir.
Okay, yes, ma'am. பேசுங்க.
Good evening to one and all present here. It gives me immense pleasure and pride to deliver this valedictory address for this 6 days faculty development program on emerging trends in IoT, jointly conducted by the Department of Electronics and Communication Engineering, Electrical and Electronics Engineering, and Department of Mechanical Engineering. First and foremost, I express my sincere gratitude to our Honorable Chairman, Dr. R. Narayanaswamy, and our Secretary through MDG Rajkumar, other trustee members, and our beloved Principal, Dr. B. R. Ramesh Babu sir, and Dr. P. Mahesh of Dipli Department for their constant support and encouragement in organizing this faculty development program successfully. Nearly 400 participants have registered for this faculty development program, and this FTP has been a remarkable journey of learning, exploration, and collaboration. The sessions conducted during this FTP have covered a wide spectrum of topics from IoT architecture, technologies and protocols, IoT for smart grid and energy management, IoT applications in smart systems, IoT in avionics, using Gen AI to analyze sensor data, behavioral IoT, and edge computing and cloud platforms in IoT. These sessions have not only enhanced technical knowledge but also provides practical insights into real-time applications. I extend my heartfelt thanks to all the distinguished resource persons, namely Mrs. K. Devadarshini from Pollachi Institute of Engineering and Technology, Dr. D. Satyaraj from Arjun College of Technology, Dr. P. A. Prasad from Arjun College of Technology, Dr. G. S. Annie Grace Vimala from Savita School of Engineering, Dr. N. Murugan from Arjun College of Technology, and Mr. S. Jim Reeves from Mallareddy University, Telangana for sharing their valuable knowledge, expertise, and they brought real world insights in the field of IoT. I would like to record our sincere thanks and appreciations to our host institution resource persons like our principal B. R. Ramesh Babu sir and Dr. S. Krishna Kumar sir, professor and head Triple Department for their invaluable contributions. And these resource persons have made each sessions informative and engaging, and your contributions have truly elevated the quality of this program. I would also like to thank the organizing committee and the conveners, Dr. S. Krishnakumar, Professor and Head Triple Department for his efficient planning and coordination, and Dr. G. Suganya, Associate Professor, Head of Mechanical Department for their valuable support. And I will also extend my sincere thanks to our faculty coordinators of this FTP program, Dr. Jay Shankar, Associate Professor, Triple Department, Mr. G. Kodiswaran, Assistant Professor from EC Department, and Mr. Parishita Alagan, Assistant Professor from Mechanical Department, for their meticulous planning and tireless efforts in conducting this program smoothly over the past 6 days. Their dedication and efficiency played a crucial role in successful conduction of this FTP. A special word of thanks to our technical team, Karthik sir and Aparna ma'am, for their commendable efforts in managing the online platform and ensuring uninterrupted sessions and live streaming throughout these 6 days. I would also like to thank all the faculty members from the Department of ECE, EEE, and Mechanical Engineering for their valuable contributions in organizing this faculty development program. My sincere appreciation goes to all the participants for their active involvement, enthusiasm, and commitment throughout this FTP. As we conclude, let us remember that learning is a continuous process. May this program serve as a foundation for future collaborations, research initiatives, and academic excellence. Finally, I thank each and everyone who has directly or indirectly contributed to the success of this program. Thank you all for your participation and support. Thank you, sir.
Thank you, ma'am, for a gracious and eloquent vote of thanks. We sincerely appreciate your words. As we draw the proceedings of a day to a close, I once again extend my heartfelt appreciation to all participants for the gracious presence and active engagement. With this, we formally conclude day 6 of the 6 days online faculty development program on emerging trends in IoT. The feedback has been shared in the WhatsApp group, so you are kindly requested to complete it to mark your attendance. Also, the e-certificate will be duly generated and sent to your registered email within 1 week. So we once again express our profound gratitude to all the distinct resource person, the dedicated organizing team, and all the participants who collective efforts have contributed to the resounding success of today's section. Thank you all. Wishing a pleasant and fulfilling evening.
Thank you, sir.